preferences set in the database, which are all stored on a central data store. The operating software we're using is Java, C, and a database of MySQL. First and foremost, since we're using Java, this software is very heavily object-oriented and utilizes abstraction. If any of you remember back to CS110, CS111, if you took those classes, abstraction is where you have a class that defines the structure of classes that inherit from it. The logic flow is designed so that all objects, all classes intertwine with each other and cross-communicate, such as the database can communicate with the touchscreen, which can communicate with the door lock mechanism, which can communicate, etc., etc. We have it set up so that the touchscreens are isolated to individual full screens, so that you can have multiple touchscreens throughout the house, and they're individualized, set per room, and it's not just one shared image across all rooms. The database schema is set up so that it can be modularly implemented depending on the software modules that you install, and to utilize modular design so that the smart house is what would the word be, future-proof? No, future-friendly, I guess. So that it's capable of that, we use runtime module implementation. And what that is a new concept, at least to me, called reflective programming, which the definition is a process by which compiled software can observe and modify its own structure and behavior. And we have it set up that if you want to implement a new hardware module, you also have to implement a new software module, which is done by abstract module design. We provide an architecture of how your modules should be designed, and then from that you can see how reflection works. This is a standard way of instantiating a class. Basic, you set it to a variable of this type, and you can call functions this way. Reflection allows you to actually call it by the class name using this sort of reflection instantiation, yielding you a new instance of the object, and then you can get methods that are within that class and invoke them using this object call. The reason why we are using it this way is we are able to designate an area where if you have new modules, you can just drop in the software class that comes with it. The central server will then loop through that directory, find all modules that exist, and instantiate them this way. That way, it doesn't have to be compiled with the central software. It can actually be done at runtime, and it doesn't have to know what, if anything, exists.
Now a little more on the touch screen. As Alex mentioned, you can have multiple touch screens around the house with multiple instances of a interface class, which extends JFrame. And through this, you can have it so that one person could be using the touch screen in one room and another person using one in another room and not interfering with each other.
Just a quick reminder later.
So, because of this, we have multiple instances of a class, and it allows for independent control without the different instances interfering with each other.
As a quick addendum to that, going back to where I mentioned the logic flow, the way that the logic is designed in the core software is that when using reflection, we can designate that there is a touchscreen method within each module that has to exist, and that can alter and add components to the touchscreen whenever implemented, so that if you have, say, one particular module that does whatever in one room but doesn't exist in another room, it will only affect the touch screen and set its display to accommodate those different settings for that one particular room by using a modular inheritance flow.
Okay. So security, that was the basis of our experimental project. We wanted to focus on this, and as Zach said earlier, we're going to be using the biometrics. So we're going to use the fingerprint. Now, some of the issues we had was actually communicating and integrating between the fingerprint scanner, then through the computer to the microprocessor. But once we got that all situated, we have an external lock, which is, we made it go to fail-safe or fail-secure?
Fail-secure.
Fail-secure. And it's simply, once it's activated through the fingerprint and it recognizes you as an occupant of the house, you'll be allowed access by sending a simple 12 volts to the lock itself, and access will be granted. We also have our proof of concept is remotely actuates a door locking mechanism. So that's good right there. In the fail secure configuration ensures that the home will not be vulnerable if the power is cut. That's pretty much the concept of fail secure. In power management, we will regulate the power usage and ambient conditions through our the user-friendly interface, where the users can actually set the house on sleep mode, which will save power. Like say you're sleeping and you're not going to be really using the immediate features or the light dimming features. Everything's going to be set to one thing. And right there we have the lights. We're going to be utilizing pulse width modulation to adjust the brightness according to the user preferences. And also the blinds will be using the same concept, but in addition to a stepper. And to sum things up, our system is modular, as we've been mentioning before. The components are linked through USB all throughout the house. Now we were asked why not wireless, and using the USB, it's for one easier, two lower cost. Maybe if we had more time, we could implement the wireless as needed, but the USB is very solid to use. So and without, it'll be friendly to the eye too, because you can hide USBs in the walls and the ceilings, even underneath the baseboards, run throughout your house, so it won't be an inconvenience. Everything is low cost, pretty much. We can get everything off the shelf. That's where we got a lot of our products, and it's configurable. Our software is built using object-oriented languages, as we mentioned before. Updates, modifications will be very easy to implement.
Questions?